and welcome back to biology. So today we're diving into photosynthesis. We're in the chloroplast now, looking at photosynthesis, and really we're going to talk about the first part of photosynthesis, and that's the light reaction part of this. So photosynthesis is actually two processes working together, much like how cellular respiration was three kind of working together. Photosynthesis is two. The common way to think about it is the two parts to it, the light reaction and the Calvin cycle, is that the light reaction, this part here, this is the photo part of photosynthesis, because this part uses light. It's the light reaction, light's made of photons, so that's the photo part, the light using part. And then the Calvin cycle, this part over here, this is the synthesis part, because synthesis means to make or to build. So the Calvin cycle then is building the sugar. So the sugar that we get out of photosynthesis is made during the Calvin cycle. But in this video, we're going to start by looking at just the photo part of photosynthesis. So let's look at the light reaction. So the light reaction runs off of an electron transport chain, similar to cellular respiration. This is also going to occur in the thylakoid membrane. So the thylakoids are little green pancakes on the chloroplast. That's where they're going to occur. And for here, we still have an electron acceptor, but for photosynthesis, the electron acceptor this time is what we refer to as NADPH. So NADPH it's the same purpose of the electron acceptors as what we saw in cellular respiration, but it's just a different molecule doing the same job. So, and in here, we're also going to make ATP. The ATP synthase enzyme is also available here. So let's just look at the process of cellular respiration. So photosynthesis. So here's what the electron transport chain looks like, is this part right here. So what we see is here's this series of enzymes, of proteins, carrier proteins here that are going to transport the electrons across the membrane. And two of the important ones are these photosystems one, photosystem 2 and photosystem 1. And if you're looking at this and you're wondering, well, why does photosystem 2 come before photosystem 1? Because we discovered photosystem 1 first, then we discovered photosystem 2. But what the photosystems do is they capture the light. So the photosystem, this is where like your chlorophyll is the light capturing pigment. This is where they're at. They're in the photosystems here. In the light, it's going to excite these electrons that are in the photosystem. Excite the electrons. Pass the electrons along this chain here. And then in the end, through the final enzyme, there we're going to get NADPH. Now, that's great, but where do the electrons come from that are being excited by the light and being passed along the chain? Well, they're coming from water. So water, this part right here, water is what's actually giving us the electrons. So water, we actually get the electrons by breaking water, by splitting water. And when we split water, we get two things. We get oxygen. So the oxygen in photosynthesis comes from this breaking of water. And plants don't need oxygen, so they're just going to ship it out through the stomata and just out into the atmosphere, which then we breathe in later. The other thing is when we also break water, we get these two hydrogens. Really, they're just protons because the electrons are moving through the electron transport chain. So it's just some protons. So now we have a protein gradient build up again, much like what we had in cellular respiration. This side is filled with a bunch of hydrogen ions, bunch of just protons. Well, they don't like being near each other, so they're going to try to get away from each other. Well, then the only place they can move is down and into the stroma through ATP synthase. Same enzyme that made ATP in cellular respiration is making ATP here. ATP synthase, as each hydrogen and each proton crosses ATP synthase, it's going to make ATP. And then the ATP that's made, and then the ATP that's made from the ATP synthase, and NADPH that's made from the electron transport chain, both of them are going to go to the Calvin cycle. So that's the important parts here, is this water splitting, oxygen, and that's where oxygen comes from, the water. So make sure you're just focusing on the inputs and the outputs. Our inputs are light and water, outputs, oxygen, NADPH, ATP. So let's just talk a little bit about light. So light, how it works is the pigments are chlorophyll. So this is what chlorophyll looks like right here. And that's all a photosystem is just the arrangement of these pigments, of this chlorophyll. There's other molecules as well, other pigments that we use to capture light with that help in photosynthesis. But let's just look at chlorophyll for right now and light. So light's really good at, exciting electrons, but we need something to absorb the light through, or at least absorb the wavelengths, because light exists as a wave. That's one of the forms that exists as a wave. So chlorophyll, if we look at chlorophyll here, and if we look at the absorption spectrum of chlorophyll, we have two different chlorophyll molecules, chlorophyll A and chlorophyll B. So chlorophyll is really great at absorbing blue light, this kind of blue purplish light that we see down here, or violet light, sorry. Super good at absorbing that. And it's also really good at absorbing the other end of the spectrum, red and orange light. So chlorophyll is great at absorbing light at the ends of the spectrum. All right, really good. But it's not great. It's kind of sucks at absorbing green light. If you see on the absorption spectrum, the green light down here, chlorophyll almost absorbs no green light. So then that asks the question of, why are plants green then? If they don't absorb green light, what are they doing with it? Well, what they're doing with it is they're reflecting the light. And that's how color works. So plants are green not because they're using green light, but because they're reflecting the light, the green light, back at us. So they're absorbing all the other light and then they're reflecting the green light. So we do have other pigments as well that help us with that, xanthophylls and carotenoids, each with their own different color and pigment and whatnot. So a little bit more, just real quick here. So the light absorption spectrum, if we were to look at it, this is what it is. So light exists as a spectrum all the way from gamma rays to radio waves. On the left, as we start with the left, the waves down here have a short wavelength but a high energy. So these waves are going to look something like this. All right. Short wavelengths, the distance between the waves are short, and they're higher, so they will have more energy. As we proceed to the right, the wave gets bigger, but we also have lower energy. So this is what, as we move, the waves shift to have a longer wavelength and lower energy. So red has less energy than what violet or blue does. So that's it for this video. Let me know if you have any questions, and I'll talk to you later. Bye.